Okay, let's go ahead and practice working with fractions. And this particular problem seems pretty basic on the surface. We have 2 3/4 plus 1/2 times 5/3. Shouldn't be too difficult. However, I'm going to tell you right now, if you don't pay attention, if you don't focus, it will be easy to stumble into an error and, of course, how to make your answer wrong. Now, I'd like you to do this problem without the aid of a calculator. So put those calculators away. If you didn't know, you have a supercomputer way up here in between your ears, and that is not artificial intelligence. That's the real stuff right there. So go ahead and do this problem without the aid of a calculator and put your answer into the comment section. I'm going to show you the correct answer here in just 1 second. Then I'm going to fully explain how to do a problem like this. But before we get started, let me quickly introduce myself. My name is John. I have been teaching math for decades. I love to teach math, and it's my true passion to try to make learning math as easy as possible. So if you need assistance in mathematics, check out my math help program at tcmathacademy.com. I'll leave a link to that in the description of this video. And if this video helps you out, don't forget to like and subscribe, as that definitely helps me out. Okay, so let's go and take a look at the answer here. And the answer is the following: 43/12. Okay, this is what we call an improper fraction. Now, if you wrote this as a mixed number fraction, you'll just have to make that comparison to see if you did this correct. But let's just, I'm using terms here, mixed number fraction, improper fraction. Let's just do a quick power lesson. If you have a fraction like 1/2, well, actually, let me write a few fractions up here: 3/2 and 3 1/2. Okay, so when you have a fraction and the denominator, which is the bottom number, is bigger than the top number, which is called the numerator, this is called a proper fraction. Now, when the numerator, this top number again, is bigger than the denominator, this is an improper fraction. And these type of fractions like this can be turned into what we call mixed number fractions. And mixed number fractions can be written as improper fractions. Okay, so that's a whole kind of little procedure that you have to learn. Not difficult, and I'll talk about that as we go through this problem. But anyways, this is the correct answer: 43/12. Now, if you didn't get this right, don't despair. I'll show you exactly how to do this problem. But if you got this right, that is awesome. Let's celebrate by giving you a nice little happy face, an A plus, a 100%, and multiple stars. You can tell your friends and family that indeed you are an expert in fractions. Okay, so let's go ahead and get into the problem. Now, when you take a look at any math problem, right, you have to kind of scan to see what's going on. So what do we have? Well, we have a number. Now, this number happens to be expressed as a mixed number fraction, but it's a number. We're taking a number, we're adding it to another number, and we're multiplying it by another number. Okay, so we have to kind of scan what's going on. You know, it's like going into the jungle or walking into some place you're unfamiliar with. Before you start walking, you need to stop and pause and scan, see what's going on. Same thing here when this particular math problem. So we have addition and we have a multiplication. Now, it will make a huge difference, okay, in terms of the answer you get if you do the problem in this order versus this order, right? So in other words, if you decide that you're going to add these numbers first and then multiply, you're going to get one answer. But if you say, no, what, I'm going to multiply first and then add, well, you'll get another answer. So we need to consider these operators, okay? Now, in mathematics, we have these things called math operations or mathematical operators. So these things like addition, subtraction, multiplication, division, even powers, these are examples of what we can do with numbers, okay? I.e. math operations. Now, I can assure you math operations are way better than an actual medical operation, right? So we're not talking about shoulder surgery, knee surgery. These are math operations, much funner to deal with than, obviously other types of operations. But when you hear a word like an operator or operations in mathematics, math is a language. You need to understand, these terms. Now, what we're trying to figure out is what order do we do this problem in? Well, luckily for us, we have this thing called the order of operations. So here's all these different possible operations that we can face in math. What do we do first? Well, we have this lovely saying right here that will guide us, okay? So it's called PEMDAS. You can kind of say it as PEMDAS, but this is a description for what we call the order of operations in mathematics. Now, there's a cute little saying that goes along with this phrase. I'll say it right now. Please excuse my dear Aunt Sally. That saying has been around, oh, I don't know, probably your great great grandparents were saying that back in middle school. But anyways, please excuse my dear Aunt Sally, PEMDAS. So this is an acronym or a little mnemonic, a memory aid that will help us with the order of operations. So let's go through this real quick. So what does the P stand for? The P stands for parentheses, but also stands for grouping symbols, things like brackets or these kind of squiggly brackets. So if you see any of these, this is where you're going to start. Okay, so if you see any parentheses, you're going to start there. Now there's, I'm kind of going through this pretty quickly. So to really master the order of operation, you need to do a wide variety of problems. I'm just kind of going through the basics here. So that's what P stands for. E stands for exponents, but you can think of that as power. So if you see anything like 2 squared, 3 to the fourth, that's what we do next. Now, the next thing here, and this is such a common misunderstanding, is most students will be like, oh, I'm going to do multiplication next, right? I'll do multiplication, then division. That's not the case, okay? What you're going to do is you're going to consider, do you have any multiplication or division? And you're going to do whatever you see comes first from left to right. So if you have multiplication, then division, then this is M and D. If you have division, then multiplication, well, that's the order you would do it in, D and M, because this comes first from left to right. So that's a very, very common misunderstanding. And then the same thing holds true, excuse me, for A and S, which is what? Addition and subtraction. So multiplication, division, addition, and subtraction. Okay, so this is what we need to apply in order to do this problem on top of being able to work with fractions. So let's go ahead and get into it now, being that we know what is the correct order. So when we kind of scan through our little PEMDAS, right, we're like, oh, do we have any parentheses? No parentheses here, so we gotta kind of forget about that. Do we have any powers? Things like 2 squared? Nope, don't see any of that. So now we have to consider multiplication and division. And the only thing we have here is multiplication. And multiplication will always trump addition. So this is the part of the problem we need to start with. Okay, so that's the first kind of like challenge, is to make sure you have the correct order. Now the second challenge is actually working with fractions. Okay, so now let's go ahead and get into this right now. So 1/2 times 5/3, what is this equal to? Well, I'm going to show you this in just one quick second, but I want to remind those of you out there that maybe are benefiting from my content. I've been on YouTube for a long time. I put a lot of effort into it because I love teaching as many people as I possibly can, but it really does help for those of you that do subscribe. So thank you very much if you are a subscriber. If you are not, it does help me a lot. And if you do subscribe, please hit that notification button as you'll get my new content. I generally post every day. But let's go ahead and continue on with this problem. All right, so 1/2 times 5/3. That's what we have to figure out. Now, this is super easy. Let me make another observation here. When you are working with fractions, you can use this little slant bar style to write fractions. So here you can notice I'm writing a fraction as 1/2, and over here I'm writing it with a horizontal bar, 1/2. This is perfectly fine. However, I'm going to, what I'm going to say is if you like writing your fractions this way, get used to writing them this way, okay? And there's benefits to this, especially in algebra. So try to, create the habit of writing your fractions with a little horizontal bar. It will help you out in the future. Doesn't mean that you're wrong in the least. It's just going to make it easier for you to do work, especially in algebra. Okay, so here we go. We got 1/2 times 5/3. How do we multiply fractions? This is super easy. All we need to do is multiply the respective numerators and denominators. So 1/2 times 5/3 is going to be equal to 1 times 5 over 2 times 3. And when we do this work, we have 1 times 5, of course, is 5. 2 times 3 is 6, and there you go. That is the answer, 5, 6. Okay, so where are we at? Well, again, we kind of looked at the problem. We figured out through the order of operations, this is what we need to do first, and we did that, and we came up with the answer 5, 6. So this is the problem as it stands right now. We have 2 and 3/4 plus 5, 6. So I know you guys are super excited, like, all right, awesome. We get to add fractions now. Yes, indeed, we have to add fractions, but the easiest way to add fractions, well, I want to suggest kind of the primary way. There's different ways you can think of adding fractions, especially when you have a mixed number fraction. But the easiest way, generally speaking, is to take your mixed number fractions, like 2 and 3/4, and when you have a mixed number fraction and you want to add it or subtract it with an improper or proper fraction, you want to take this fraction here and write it as an improper fraction. So you want to get out of working with mixed numbers. You don't have to do that. I could break this up and do this other ways. And if you took another path, that's perfectly fine if you got the right answer. But let's just review 2 and 3/4. We want to write this as an improper fraction. So we take this 4 multiplied by 2, right? 4 times 2 is 8. Then 8 plus 3 is 11. That is our numerator, and that's over 4. Okay. Now, if I'm going a little bit fast for you in terms of all these skills, you're like, yeah, I kind of remember that. Let me suggest something. I have an awesome little mini course. It's called my Math Foundations course. You'll find it in the description below, but it's basically, it goes through all basic math to include fractions, or you got to be a basic math expert if you want to succeed in things like algebra. Okay, so anyways, we have 2 and 3/4. We wrote it as an improper fraction, 11 over 4. And then, of course, we have our 5 over 6. Notice again, I'm going from the slanted fraction bar style to this horizontal style. So now we have to figure out this problem here. Now, if you have been watching my videos for some time, I've done multiple videos on how to add and subtract fractions. There is a great shortcut technique where we don't have to use the LCD. And maybe I'll try to show you that if we have a little bit of extra time in this video. But right here, we're trying to add these fractions, but we cannot add these fractions because the denominators are not the same. Okay, you can only add fractions when the denominators are the same. So in other words, if I had 1/7 plus 3/7, I can add these because these numbers are the same. Here they are not. So we need to figure out how to write these fractions such that their bottom numbers and denominators are in fact the same. We call that finding a common denominator. And there's a bunch of common denominators, but what we want is the lowest common denominator. Okay, so here we go. How do you find the LCD? Well, this is a whole nother thing in fractions that you got to master. And this particular problem, it's super easy to identify the LCD. Most students can, because you're thinking to yourself, you're like, okay, you're kind of, what is the lowest number that both 4 and 6 can divide into? So you're thinking, oh man, I think it's 12. Let's see here. I can divide 6 into 12 without a remainder, and 4 I can divide into 12 without a remainder. So it's 12, right? There's no lower number. So that would be the LCD. And that's a good way to think about it. But if you wanted to actually find the LCD, that's a whole nother procedure. So here you're like, I don't care about your procedure. I already know how to do it. Well, these are easy numbers. What if I made the denominators like 408 and then over here I had this at 62? Then your expression would really be like, I don't know how to do that and I don't want to do that. I'm going to, I'm going to go do something else. I don't blame you, but it's not that difficult. Let me show you here real fast. Quick review. So here, to find the LCD, what you want to do is take your denominators and write them as prime factors. Okay, so in other words, 4 is equal to 2 times 2. 2 and 2 are factors of 4, and we want to write that as a power. So 4, the prime factors of 4 is 2 squared. 6 is equal to 2 times 3. These are factors of 6, and these are also prime numbers. So 2 and 3 are prime numbers. So what you want to do is when you're finding the LCD is you want to have each of your prime factors here between all your denominators, here we're just dealing with 2, represented in your LCD. So in other words, you're going to have each unique factor represented. So here we need a 3, that'll be a part of our LCD. And here I have a 2 squared and 2 to the first. Anytime you have powers with the same base, like 2 to the second, 2 to the first, 2 to the fifth, doesn't make a difference. You always take the highest power. So we're going to take 2 squared. We don't need to have 2 to the first because this 2 squared represents that. Now look here, 2 squared is what? 4. 4 times 3 is 12. So that is the procedure on how to find the LCD, and that will come in very handy when you're dealing with larger numbers or larger denominators. Okay, so now let's continue forward. I know it's like, boy, this is a lot of work. Well, I am, kind of explaining it step by step. But let's now think about what we need to do. All right, great. We need to use the LCD. The LCD is 12. What does that mean? Well, it means that we need to rewrite each of these fractions such that their respective denominators is 12. Okay, so how can I take this fraction and change it into another equal fraction or equivalent fraction where the denominator is 12, and this fraction rewrite it such that the denominator is 12? Well, this is how you do this, right? You're like, okay, well, all right, so I have a 4. How can I turn this into a 12? Easy. We're just going to multiply it by 3 because 3 times 4 is 12. So that's how you have to think about it. But when you multiply the denominator by whatever number you need to get this number, you also have to multiply the numerator. So in this case, 3 times 11 is 33. So these two fractions here are the same. If I said, hey, take this fraction and reduce it, you'd get back to this fraction. So you're just changing the fraction. You're just writing it. You didn't break it or anything like that. You just write it in such a way that its denominator is 12. Okay, so let's go ahead and take a look at this denominator. We have a 6. We want to turn it into a 12. Easy, just multiply by 2, right? 6 times 2 is 12, but we need to multiply the numerator by 2, so 5 times 2 is 10. Okay, finally, we have two fractions where the denominators are the same, so we are ready to take the next step. Okay, so anytime you're adding adding or subtracting fractions and the denominators, these numbers down here, are the same, all we need to do is to add the respective numerators. So that would be 33 plus 10, which of course is 43. I'm sorry, yeah, 33 plus 10, which is 43 over 12. Okay, now at this point, what you want to do is to make sure that you fully simplify, fully reduce any fractions. In this particular case, you cannot. Okay, and you might be saying, well, I know 3 goes into this and 4 goes into this. It's good to know the divisibility rules. If you don't know the divisibility rules, the divisibility rule for 3 is awesome. Okay, so let's take 12. Okay, now we know that 12, you can divide 12 by 3, right? The answer is 4. Okay, but what is the divisibility rule? I'm kind of stumbling on my words here. And this comes in handy when you are looking to reduce fractions. So the sum of the digits, okay, so here's 12. If I add up the sum of the digits are 1 and 2, okay? 1 plus 2 is 3. If the sum of the digits is divisible by 3, then the number itself is divisible by 3. So you can see here 1 plus 2 is 12 is 3. Well, of course, 3 is divisible by 3. Let's practice another problem, 15. Okay, we know 15 is divisible by 3. Why? Well, 1 plus 5 is 6, right? These are the digits of 15, and 6 is divisible by 3 without a remainder. Okay, so when I look at this number, 43, you could just go, oh, 3, the sum of the digits is 7. Well, 3 can't go into that, so forget that. And then you can check 4 real quick, but there's other divisibility rules for multiple numbers, 5, 2. You should know those as well. All this stuff I cover again in my Math Foundations course. Now, let me make one other comment here. Actually, two other quick comments is the following, right? So at this point, I'm going to try to spare you a lot of tears on math tests, okay? Now, through the decades, right, I have probably graded maybe 10 million test quizzes. No, not that many, a lot, okay, to definitely see enough mistakes. And one common mistake is a student, let's suppose they get this problem right, and they have the problem as an improper fraction. It's fully reduced, it's awesome, but they get motivated to turn this into a mixed number. For example, if I have 3 over 2, all right, that's perfectly fine. So how do I turn this into a mixed number fraction? You take that 3 and divide by 2. Okay, so that's what 2 goes into 3, 1. 1 times 2 is 2. Subtract that, we get 1. So that's 1 and 1/2, right? Because 1 and 1/2 is, here, 2 times 1 is 2 plus 1 is 3/2, right? So this is the mixed number equivalent. But this answer right here is perfectly fine. So what a lot of students do, they think it's necessary and it's not, and I do not recommend it, is they'll take their improper fraction and then they'll do all this work to get a lovely mixed number. But as they're doing this division work, okay, you need to know how to do this, okay, but don't volunteer to do it. As they're doing this, they'll make an error, like a 1 1/3. Then they turn in this problem as their answer, and when I mark it wrong, then they'll have this kind of expression. They'll be, generally kind of angry. They'll be like, "What are you doing, Mr. Math teacher? Give me my points. I teacher, I knew it, I knew it, I knew it. Look, here's the answer. I had it right, but you turned in the wrong answer because you did some extra work. Okay, don't do that. Okay, don't." Make that error. So that's another little bonus tip here for you. Real fast, I promised you, I don't know if I did or promise, but let me show you real quick. You've got to watch more of my videos on this technique, but for those of you who have not seen that, I'm going to show you a quick, awesome little way to add these fractions, okay? So one thing you could have done is you could do this bow tie method. So you can go this times this times this times this, okay? So you're going to do this in this order. You definitely have to watch more of my videos on this particular method, how to add and subtract fractions. It's a shortcut, but what you could do is go 6 times 11 is what? That's 66 plus, this is an addition problem, 4 times 5 is what? 20 over 4 times 6 is 24, okay? So we add this up, that's going to be what? 86 over 24, and 86 over 24 is going to be equal to 43 over 12. Okay, so let me go back up here, and we have 43 over 12, right? So that's the actual answer, but I just did this real quick. All I need to do is reduce this fraction. 2 goes into 86, 43, and 2 goes into 24, 12. So you might be saying, wow, that's super easy. This is a great shortcut. The only drawback on this is that you may not get the lowest common denominator. But anyways, I did mention it, so I figured let me show it to you. But again, I can't possibly teach you everything in this one video. I got to stop myself. I could just go on and on teaching math. I love mathematics. Hopefully, I'm inspiring you to get better at math. Okay, remember, math is it's just a collection of skills. So whatever you're struggling with, you can learn. You just got to break it down into its respective sub skills. Okay. All right. So with that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.